Writing chemical equations is a really important skill in grade 11 chemistry and moving forward. Being able to express what's going on in a reaction in both words and through balanced reaction equations is really important. It's like our own language that is common between chemists around the world. So we're going to do a little bit of review sort of from grade 10, talking about what are reactants, what are products, and how does a chemical reaction get expressed in both words and in symbols, and then looking at a few practice questions. So first of all, a chemical reaction, let's start with a few definitions to have in our notes here, is a process in which substances interact causing different substances with different properties to form. So these interacting substances are called the reactants. Okay, so reactants are, a reactant is a starting material or a starting substance, we'll say, in a chemical reaction. And these different substances that are formed that have different properties are called the products. So a product is a substance that is formed in a chemical reaction. Now, we describe our reactants and our products both through words, in terms of the name of the compounds or elements, and through like short forms that are our equations. Okay, so these formulas that you see further down here. Now, within, you'll see in each of these formulas in the example below, that each one has a little subscript. Now, these subscripts are called state subscripts, and they indicate the state of each thing in a chemical reaction. So solids, okay, are indicated by the little s. So example here, like a metal, like copper or silver, are going to be pure solids. So an example here would be like metals, with the exception of mercury, which is a liquid. Now, L, you won't see too often. The little lowercase l, which I tend to write like a cursive L when I do it so that it doesn't look like a 1. This is indicating a pure liquid. So the key word here being pure. So an example of that would be something like water. So something that's purely that thing. There are very few pure liquids that we're going to look at in this course. Mercury on its own would be a pure liquid. Bromine on its own, if it was a single bromine, it would be a liquid, but usually you find bromine in terms of a gas. So you see those on the periodic table as being liquids, but that's not often how it's found. But water is a pure liquid. Something like ethanol, which is alcohol, like drinking alcohol, is a pure liquid as well, but water is the main one that you'll be using in this course. G is for a gas, so something that's in the gas state. So some example would be something like oxygen gas, O2, or carbon dioxide gas, CO2. Those are a couple common examples you probably have heard of before. And then AQ might be one that you might not have seen very much before, but this stands for the word aqueous. Now, aqueous means that something is dissolved in water. Okay, so these are things that look like liquids, but they're not a pure liquid. There's things kind of mixed together. So this would be something like if you see salt, so NaCl, aqueous dissolved in water, so salt dissolved in water, or lots of these compounds that contain a metal and a nonmetal, so these ionic compounds, will be dissolved in water in most reactions because they actually will have a reaction happen in a decent amount of time when they're aqueous. A lot of the times when you mix solids together, nothing really happens. So those are our state symbols, and we will be using them a lot this year. You will be expected to know what the state symbols are of most things in reactions. Now, the next important part to expressing equations is to be able to balance them correctly. So this is definitely review from grade 10, balancing equations, but we'll do a quick example here in case anybody needs a bit of a refresher. So when you balance a reaction equation, we do this so that we can show that these reactions are following what we call the law of conservation of mass, which means that no matter can be created or destroyed. So you can't have copper on one side of the equation and have it not appear on the other side, or not appear in the same quantity on the other side. So when we look at this particular example, one copper over here, there's one here, one silver, but this chlorine, see how there's only one chlorine on this side, but on this side there's two chlorines? We can't have that because this is saying that a chlorine came out of nowhere, but that can't happen. It doesn't exist. So the way that I like to balance reaction equations, if you're really quick at this, it's kind of like a puzzle. You do not need to show your work, but if you would like to kind of know a long way of doing it, this is how I would do it. So I sort of separate our reactants and our product side and make a list of all of the elements that are in the reaction. So in this case, we've got copper, silver, and chlorine. Copper, silver, chlorine. And put them in a list on both sides and in the same order. So it's easy to compare when you're counting out how many of each thing you have. Okay, so step number 2 is to make sure that you write out how many of each thing you have to start with. So we have one copper on this side, we have one silver, and we have one chlorine. On this side, we have one copper, we have one silver, but we have two chlorines. When you have a subscript, it only applies to the thing that is directly beside. So Cl2 there. When we look at this, we see that copper is balanced, okay, equal numbers on both sides. Silver is balanced, equal number on both sides. But the chlorine, we have 2 on this side, but only 1 on this side. Now, we cannot just simply remove this and call it a day because it's not the same compound as it was before. You need to add coefficients, which are the numbers in front, to balance the reaction equation and get equal numbers of everything on both sides of the arrow. So I'm going to do this in a few different colors to sort of show my steps. So chlorine here, I've got Cl2 on that side, 1 on this side. To make it so that I have 2 on this side, I'm going to put a 2 in front of AgCl, and that's going to change the number of silver and chlorine atoms I have on this side. So now I have 2 and 2, which is even. Copper, 1 and 1 is still even. Silver is now unbalanced. I have 2 on this side, but only 1 on that side. So I need to add a coefficient in front of this silver, which changes that to a 2, okay, and evens that one out. So now copper 1 is good. Silver 2 and 2 is good, and chlorine 2 and 2 is good. So now I know my equation is now balanced. We'll do one more together. If you find that you are, this is really easy and balancing is something that is not challenging at all for you, then great. You can just do this on your own and pause the video or skip through. But if you would like to do another practice question, we'll do one more together. So in this one, we've got nitrogen and hydrogen. So again, I'm going to draw sort of my little, students often call it like the river, my little line between the products and the products and reactants. I'm going to make a list. So I've got nitrogen and hydrogen, okay, on both sides. This side I have 2 nitrogens and 2 hydrogens. On this side I have 1 nitrogen, so there's a little 1 there, and 3 hydrogens, 3. So now I'm looking at this and I'm going to say, okay, nitrogen I have 2 and only 1, hydrogen I have 2 and then 3. Whenever you see 2 and 3 of something, it's a bit like math where you're sort of thinking in the same way as finding lowest common denominator. That's the same idea that you're looking for here. If you ever have 2 of something and 3 of something, you're always going to make them both 6, and that's the way to even them out. So to make them both 6, you're going to add 3 in front of this H2. That's going to make that 6 of those. And then we're going to add a 2 in front of this NH3 to make that one also 6, so that our hydrogens are now equal. And that so happens to fix our nitrogen problem as well. 2 on this side, 2 on that side. So now that one, whoops, there we go. Now that one is also balanced. Okay, moving on to our types of equations. So we have 3 types of equations. We have word equations, which are what you would expect, so you're writing out the full name. Skeleton equations, which is formulas that are not balanced, and then balanced equations, which are formulas that are balanced. So we'll give a quick definition to each of these types. Word equation, okay, is a condensed statement that expresses chemical change using symbols and chemical names. So here, if we look at the example of the word equation, we have the names of the compounds written out, and then the symbols. The pluses indicate that you have more than one thing. The arrow is showing us that this is a chemical change. The arrow indicates the change, okay, the chemical change. Do not use an equal sign, okay? It's not equal, it's a change, okay? So don't use an equal sign. People make that mistake all the time. Don't do it. Skeleton equation. So a skeleton equation is a condensed statement that expresses chemical change using symbols, formulas, and includes states. So looking at the example of the skeleton equation, I've switched here from the name to the chemical formula. I still have the pluses and the arrow, but you can also see that I've included the state symbols on each compound or element. Finally, balanced equations. Okay, a balanced equation is a statement that uses chemical formulas and coefficients to show identities and ratios. Okay, with key part being here, the difference is that is showing the ratios of reactants and products. So there's a key difference. Is not only are we showing what they are, so the identities being copper and in this case silver acetate and so on, but it's also showing with coefficients the ratios of molecules of each type within that particular reaction. So next we've got some practice questions here. So this one is to balance these equations and write out the word equation. And then in the bottom, we've got some word equations that you write out the skeleton and then the balanced reaction. Try these practice questions, so 1 and 2 now, and we'll start class by taking those up. Then we'll do some more practice in class, so don't worry about doing these yet. Just do 1 and 2 here.